Hello, this is a short section in which I update you on the ITRS table I presented earlier. In order to do that though, I first have to introduce the concept of a FinFET. Up to about the 22 nanometer node, we're using bulk FETs. That is, the field effect transistor, the CMOS gate, is built by implanting a silicon wafer with one type of material, planting a drain and source with another type of material, building a gate oxide, and then building a conductive gate above that. Of course, the field on the gate oxide modulates the channel in the bulk material underneath. Well, this is difficult to scale beyond the 22 nanometer node, and a scalable alternative has arisen, and that is the FinFET. In the FinFET, instead of just using the bulk or the body as for the channel, we actually build a fin up of the right type of material, N-type or P-type, depending on the transistor, and we build a gate around this. This is also referred to as a 3D FET because of the 3D nature of the structure. By doing this, we get better electrostatic control of the conduction channel in here. In addition, we can make this FET very narrow through various processing tricks that I won't go into. So here we have the source, the drain, and the gate are wrapped around the fin, and the transistor channel appears or not appears in the fin, depending on the voltage on the gate. Of course, the oxide is still here, it's just not shown. So if we refer to the ITRS, which comes out every 2 years, and I'm actually involved in producing it, I'm involved in the emerging research architecture section, I'm the editor of that. But this is from the summary of the 2013 ITRS. 2015 will come out actually much early next year. And what you see here is the roadmap of the advanced nodes. Of course, today early production is already starting in the 16-14 nanometer node, often typically referred to as 14 nanometer. Look at these dimensions here, of course, you notice that nothing is actually 14 nanometer. The logic half pitch, the pitch being the periodicity of the metal 1 traces, the logic half pitch is 40 nanometers. The FinFET half pitch is 30 nanometers, as the pitch is 60. But the FinFET width is narrower at 7.6 nanometers. And there's various other things here, including DRAM, RAM densities of various sorts. Here we have 3D RAM, which is a 3D transistor stack. If you take EC733, you'll learn more about that. Here it's, in the roadmap at least, we're talking about going from transitioning from 300 millimeter wafers to 450 millimeter wafers, that is a wafer half a meter wide, in 2018. VDD continues to shrink, but not very fast. You notice all these numbers are sub 1 volt. In fact, this is referred to as near VT computing. The threshold voltage of the transistors are about 300 millivolts, so we're really operating just a bit above 2 VT. You'll notice the FinFET width doesn't scale very fast, and this is because if we make it too small, we just get a tunneling diode and it's no longer a FET. And what is predicted to scale are the interconnect and half pitches and pitches and so forth. Frankly, anything beyond the 7 nanometer node is highly speculative at this point. There's clear roadmaps to 7 nanometers going on in companies. There's not a lot of clarity beyond that point. So I just wanted to update you on this ITRS table. Thanks very much.